Hello and welcome dear learners to the NPTEL course on Healthcare Quality Management, Infection Control and Patient Safety. In the Module 5, Operational Excellence in Healthcare, and in continuation with the Chapter 52, Strategic Planning for Patient Safety Part 4, we will be discussing about role of lighting in patient safety and electronic safety, communication systems, fire safety and medical glass pipeline system. So what is the role of lighting in patient safety? Lighting has both psychological and physiological impacts on patient. Natural lighting allows patients to relate to the diurnal cycle and helps maintain a normal circadian rhythm. In poorly lit environments, patient can lose orientation which may lead to fear and depression, and it is being identified that a lot of mental health problems are more aggravated only with respect to poor lighting. Access to natural light is therefore essential in all intensive care units. Illumination standards need to be followed with respect to the recommendations of the North American's IESNA RP29. The standard provides space-wise recommendations which are more emphasizing that artificial lighting becomes unavoidable in geriatric settings and ICUs. Daylight lamps replicating 6400 Kelvin are preferred as they offer artificial lighting similar to daylights. Color retention should be optimal and neither too yellow or too blue. Artificial lighting should also support the circadian rhythm and sleep pattern. So, lighting types and control. Overhead lighting and glare increases stress level and should be avoided during examination. Lighting provision should allow ambient lighting, examination lighting and reduced lighting at night. Night lamp helps maintain orientation and prevent fall. Task lighting and pre-space lighting are essential for medication administration and safe procedure. Adequate lighting in common spaces reduces the confusion and accidents with respect to patients. Lighting control should prevent unintended switching off. Centralized lighting will be the ability to control zone individually if it is preferred. Emergency lighting is all common spaces is critical for safety and should be ensured to take off. Now you can see into this figure the importance of natural light, which is for the circadian rhythm maintenance, and artificial light, that is for being seen for the daylight, and it improves actually the room orientation, and task lighting, which is more important for examination and preparations actually, where you find the night lamp is also being there for the orientation and fall prevention of the patient. So lighting system balance actually the physiological health, patient safety and clinical task. The designers need to understand that they need to prefer the cove lights and mirror optics. Cove lights should be easy to clean and designed to prevent the dust accumulation. Mirrors should not distort images and must be carefully positioned. So core critical areas require opaque acrylic covers on fixtures and prevent the light leakage. Now, with respect to electronic safety encompasses patient data, building automation system. Reliable records are increasingly maintained in electronic format. Now, as we find the importance that inadequate protection of electronic system can impair healthcare delivery system, so the importance is more increasing to protect the electronic safety part. Many healthcare facilities include firewalls, intrusion detection system and real-time detection backups, which is very important to be seen even for cases via mirror servers. Building automation system may manage lighting, power and HVAC. Integration with the building automation improves monitoring, control and safety of the part. Access control and HVAC integration. As we have even seen into the previous chapter, the importance like how HVAC needs to be seen in controllers for closed circuit television, that CCTV, which provides significant value in determining the crime, monitoring the movements of the patient and ensuring more patient safety. Camera should be placed at access control point, emergency exit and central monitoring facilities, which is very important part of the planning. Properly integrated CCTV system allows observation of critical areas, better response during the emergencies. Access control system is best deployed in critical space and non-public areas. Electronic access control should restrict. entry to sterile areas, and unauthorized movement. Access control must integrate with surgical suite overflows and restricted area protocols. Now in this particular figure, we can find the security hub and data center, where on the right hand side the patient data, that is the fire and the mirror servers, building security and data centers, where the CCTV feeds can be seen in monitoring vulnerable areas, and building automation, where building automation system is being seen as BAS. Now on the right hand side we find the restricted areas, where you need to work on the tagging and electronic access control, that only the staff can enter and other people are restricted, where the RFID tagging is very importantly being shown over here for patient safety insurance and anti wandering actually. So this integrated electronic system protection of data and managed security access to critical hospital areas, where you need to put a lot of restrictions. Now for the HVAC integration. HVAC integration systems can assist in immediate closure of dampers, smoke extraction, and switching to exhaust mode during the emergencies. Where pressure gradients are essential for infection control, integrating HVAC with building automation system improves safety. Manual controls are often difficult to calibrate accurately. Now in communication system, we can see the scope of communication system, which is including the voice system, data system, nurse call system, patient call system, and public address system. You can see so much of the systems which are evolved and which creates a network actually with a real-time feeds, which are being identified as a backbone infrastructure which needs to be very robust. Adequate redundancy is essentially identified. Reliability and redundancy. System must function during power failures and emergencies. Dedicated patient monitoring system should not be shared with others. Convenience feature should not be compromise safety. So it is very important that you need to have a sort of ethical component actually with these issues. Nurse call system improve the response times. And advanced features can be added with respect to code blue or medical staff calls or resuscitative response alerts, which are very important that the hospital needs to develop on. Hardware interfaces should integrate medical devices system and hospital information system, which is a part which is nowadays very important to increase the interfaces. Clinical communication technologies, which includes the real-time allocation system, that is RTLS, and laboratory information system, intercoms, public address system, radiology system, and these systems significantly reduce the errors and delays in responses, which are a very important component of patient safety. Now in this particular figure, you can see the HVAC system, which is maintaining the pressure for infection control and automate smoke management during emergencies, where you can find the air handler unit and the pressure gradient, which is being shown for infection control, where the patient room over here is with the positive pressure. You may come across a smoke detector which gives a fire damper close, and smoke isolation, exhaust fan, where it is in the emergency room, exhaust mode is on and smoke extraction is done out. So HVAC system proper installation is very important in dealing with the cases of emergencies. Now you can see into this particular figure, the robust communication infrastructure with redundancy ensures a rapid response to patient need and emergencies. Where at a nursing station over here, as a hub center patient monitor, you can see the different values which are being seen at a nursing station over here. The nurse call master station, where the standard call and a code blue, which is being seen as an emergency call, which is very connected actually to the bedside call button for the patient to go for a emergency, where versus for a panic call, which is being connected with the toilet actually for the patients and patients related issue, where all the code blue mechanism system can be seen with a mobile alert system, which can be seen to the nurse and nursing station with respect to the other healthcare employees or the physicians to be called up for. So you need to emphasize more on a robust communication to deal with the issues of the patient safety. Now for the fire safety part. Fire safety challenges in the healthcare are more, and fire safety in healthcare setting is becoming more complex. So patient may be immobile, patient may be sedated or on life support system. So to see that part, infinite evacuation is not feasible in hospital. So it is very important that the fire safety challenges need to be dealt according to the increasing complexity. Fire safety detection and suppression. Fire safety relies more on fire safety alarms, smoke detectors, sprinklers, hydrants and fire extinguishers, which are to be identified as the very first line and very important way of dealing with this issue. Gas-based suppression systems are preferred where water may damage the equipment. And you may come across with dry chemical powders cannot be used in operating and server rooms. So you may see that there are some sort of restrictions and some needs actually that you need to work on the fire detection and the suppression of the fire if it occurs. Evacuation and smoke management. Design must allow staff assisted evacuation. Horizontal evacuation is preferred over the vertical evacuation, which is very important part. A refuge area should be created within fire zones and which is essential while the planning of the institution. 4 plates greater than 500 square meter should be subdivided. Elevator lobbies should serve as the refuge zones. Smoke inhalation is a major cause of death in fires and which is being identified in many instances. Building design must prevent smoke spread using fire alarms, integrated building management system, automatic HVAC shutdown or exhausted mode. So this the emphasis of evacuation is being emphasized with respect even with the emergency lighting and phosphorescent signages support safe evacuation in a time of dark. Now, in this particular figure, you can see the fire safety strategies which are relying on zoning, containment and horizontal evacuation to refuge areas. So, you may find a fire being happen over here and you may come across a horizontal evacuation route which is being seen over here where 2 hour firewall zoning is being insulated over here, and you may come across a fire lift for firemen, immobile patient actually, which is having a proper signages, and a fire zone area that is called as a refuge area, which is to be emphasized more in the designing part. And this particular figure highlights actually the importance of fire safety strategies which are to be gauged and can be done with this way. Medical gas pipeline system, that is MGPS. Medical gas line system risks are centralized medical gas line system provides critical gases and they systems may pose a risk to unstable internal gas movement or improper design or installation, where the standards and codes needs to be seen according to the National Fire Protection Association, that is code 990201, and other equivalents that govern the design and installation of this important and life-saving in engineerings. Installation and safety measures. Installation requires inert gas purging, that is nitrogen, and removal of residual oil and debris. Pipeline must be color coded and directionally marked. Zoning and bifurcation ensure isolation during emergencies. Terminal outlets must fail to safe and compliant with respect to DISS, that is diameter index safety system, where it emphasizes that how this medical gas line pipeline system, if it installs, need to be handling the critical part. The centralized MGPS with color coded and DISS compliant outlet ensures safe and reliable gas delivery, which is being seen with respect to the green in oxygen, medical air, that is MA, being shown in yellow, and vacuum, that is VAC, being shown in white. The area pressure alarm panel is also being displayed over here, and you may find the connector as well as the part with respect to the uh, system is more being color coded, which gives you more a reliable gas delivery and ensure the safety part. Monitoring and maintenance is very important for this to operate under pressure, which is a continuous monitoring is required to prevent the leakages and cross contamination. Bacterial section test must be conducted and strict adherence to the standard is essential. In summary to this chapter, I would like to emphasize more on the lighting system which supports the healing, orientation and medication safety and fall prevention through appropriate natural and artificial illumination. Electronic and automation system enables the reliable operation, real-time monitoring and integration of the HVAC, power alarms and data system. Access control and surveillance protection patients and staff by restricting unauthorized movement and enhancing the monitoring of critical areas. Communication system plays a very important role ensuring the rapid ensure part and continuity of care. It also reduces the errors, especially during emergencies. And in last, the fire safety system focuses on detection, compartmentation and smoke control and safe evacuation in environments with vulnerable patients. Medical gas line pipeline system provide life-sustaining gases and require a stringent design, monitoring and fail-safe controls. And the integration system planning ensures the patient safety through a coordinated design, redundancy and continuous monitoring rather than an isolated solutions which are identified in a last way. So with this we come an end to this chapter. Thank you and thank you for the patience listening.